You probably use networks constantly, like every single day, and maybe don't even think about it much. Checking your phone first thing, asking your smart speaker about the weather. They're just kind of there, right? Running
Right.
everything behind the scenes. But what actually are they? And, how much do we really get about how they work and impact us? So, this deep dive, we're going to try and pull back the curtain a bit on the basics of the fundamentals of computer networks. Our mission really is to give you a clearer map of these essential building blocks of our connected world. We're drawing on some great material here, specifically fundamentals of computer networks and connectivity. And hopefully by the end of this, you'll have a much better picture of these digital roads you travel every day, turning these abstract ideas into something more concrete. Okay, so let's just dive right in. The absolute foundation. Our source defines a network pretty simply: a group of two or more devices connected together to share information or resources. Sounds simple enough, right? But when we talk about sharing, what's really going on there? Why connect them in the first place? What are we actually sharing?
Yeah, that's the key question. And it's gone way beyond just, sharing a file or a printer, though that's still part of it. It's really about creating these distributed systems,
Yeah.
sharing processing power, accessing cloud apps, making things more resilient because data isn't just stuck in one place. So devices connect to, well, access huge amounts of data, run complex calculations together, use applications hosted somewhere else entirely. It's about extending what a single device can do. Our source uses this analogy, the digital road system.
Oh, yeah, I like that one.
Right, devices are the cars, cables or Wi-Fi are the roads, data is the traffic. It's a neat, simple way to picture that flow of information.
Yeah.
But it's important to remember these roads aren't always clear. There's traffic jams, detours, security checkpoints.
Right.
It gets complex fast.
That road analogy really does help visualize it. And yeah, thinking about traffic and checkpoints makes you realize how many of those digital roads you're hopping on and off in just like an hour. But okay, just like real roads, you've got little country lanes and massive interstates. Networks aren't all the same either, right? They differ quite a bit in size and purpose.
Our source talks about four main types. Let's unpack those.
Exactly. And understanding these different scales is crucial. So, smallest scale first. We have the PAN personal area network. Think really short range, like Bluetooth connecting your phone to your earbuds or your smartwatch. It's all about your personal bubble of devices. Super convenient.
Okay, PAN personal bubble. Got it.
Then you step up to a LAN local area network. This covers a limited area. Your home Wi-Fi network, that's a LAN. The network in your office building or maybe across a school campus. The key here is it's usually contained, maybe managed by one group, and offers pretty fast connections within that area for sharing local resources.
Right, like the school Wi-Fi example. Precisely. Now, bigger still is the MAN, the Metropolitan Area Network. As the name suggests, this can cover a whole city or a large town. It might link up several LANs from different branches of a company across the city, or maybe connect all the libraries or city government buildings. It bridges that gap between local and much wider areas.
Okay, so LAN is local, MAN is citywide.
Yep. And finally, the biggest one, the WAN, Wide Area Network. This is the long-haul stuff. It connects networks across large geographical areas, could be states, countries, even globally. The most obvious example of a WAN, the Internet itself. It connects countless LANs and MANs all over the world. And it's pretty amazing when you think about it, how the scaling works. It supports everything from your fitness tracker syncing data, PAN-LAN, right up to global video calls and worldwide websites. WAN, these layers all work together.
That's a great overview of the sizes. So we've got personal, local, city, and global scale roads. But sticking with the road analogy, some roads are public highways, anyone can use them. Others are private roads, maybe with a gate. So how does network access work? Who gets on these different types of networks? Because clearly not everything is open to everyone, right? And that seems really important.
Absolutely crucial. Yeah, access control and security are fundamental. Our source breaks this down into three main categories based on who gets access: the Internet, the Intranet, and the Extranet. The Internet, well, that's the one we all know best. It's the global public network. Billions of devices connected, vast amounts of information. If you're browsing Google, watching YouTube, scrolling TikTok, you're on the Internet. Open access, generally speaking.
Okay, the public highway.
Exactly. Now, an intranet is the opposite. It's a private network used only inside a specific organization. Think about your workplace or school. When you access internal documents, company portals, or maybe a specific learning platform like Canvas while you're on the school network, that's usually the intranet, it's walled off from the public internet for security and privacy, only authorized internal users allowed.
So intranet internal makes sense, like a private company campus.
Precisely. Then you have the extranet. This one's a bit of a hybrid. It's also a private network, but it's designed to allow specific external users limited access. So imagine a company gives its suppliers access to check inventory levels via a secure portal, or when you're at home and use a VPN, a virtual private network, to connect to your school's network to access something like Canvas.
Ah, okay, so the VPN is creating like a secure tunnel into the private network from the outside.
Exactly. You're using the public internet, but the VPN creates a secure, encrypted connection, basically extending the private network's boundary to include you temporarily and securely. So that's the extranet concept. So the source gives a handy tip. Intranet is purely internal. Extranet allows controlled external access. It's about managing those boundaries carefully.
That distinction is really helpful. Internal, external with permission.
Got it. Okay, so we know what networks are, the different sizes, the different access levels, but what about the actual stuff? The physical hardware, the boxes and wires.
Right.
What are the key pieces that make all this connectivity happen? The traffic lights and the road signs of the network. Great question. Yeah, let's look at the key players, the devices. Each has a really specific job. First up, probably the most common one people recognize, the router. Its main job is to connect different networks together and direct traffic between them. So your home router connects your home LAN to your internet service provider's WAN, which is part of the internet. In a company, routers connect different departments' networks. They look at the destination address on data packets and figure out the best path. They're the smart traffic directors for between networks.
Okay, router connects different networks. What about connecting things inside one network, like all the computers in an office?
Ah, that's where the switch comes in.
Yeah.
People often confuse them with routers, but switches work within a single LAN. They connect multiple devices, computers, printers, servers together on that local network. Switches are smarter than older hubs. They learn which device is connected to which port, so they send data only where it needs to go within the LAN. Much more efficient.
Switch for inside, router for between.
Okay. Then you've got the access point, or AP. This is what gives you Wi-Fi. It connects to a wired network, usually via a switch or router, and then broadcasts a wireless signal that your laptop, phone, tablet can connect to. It's the bridge between the wired and wireless worlds within a LAN.
The Wi-Fi box, basically.
Well, essentially, yeah. Though sometimes it's built into the router itself in home setups. Then there's the modem, kind of an unsung hero. Its job is crucial. It modulates and demodulates the signal. It translates the digital data from your computer network into a format that can travel over your ISP's line, whether that's cable, DSL, or fiber, and then translates the incoming signal back into digital data. Without it, your LAN and the ISP's network couldn't communicate.
Translator. Got it.
Exactly. And then we have the fundamental roles of the devices using the network. A client is any device requesting information or services. Your laptop, your smartphone asking for a web page, your smart TV streaming a movie, those are all clients. And the server is the device or system providing that information or service. The web server hosting the web page, the mail server handling your email, the file server storing shared documents.
Client asks, server provides. Simple enough.
Right. And all these pieces, router, switch, AP, modem, client, server, they all have to work together seamlessly for you to, say, just browse a website.
That's a really clear breakdown. It shows how specialized each piece is. Okay, let's try and tie this all together. Our source material gives a nice practical example. Let's walk through it step by step. Imagine you're opening your school laptop, connecting to the campus Wi-Fi, and logging into Canvas to submit an assignment. How do all these concepts we've discussed fit into that simple action?
Perfect example. Let's break it down. So you open your laptop on campus and connect to the Wi-Fi. Boom. You're now part of the school's LAN, the local area network. The device providing that Wi-Fi connection is an access point, which is connected to the school's wired network infrastructure, probably through a switch. Your laptop here is acting as a client.
Okay, on the LAN via the AP, laptop is the client. Makes sense.
Now, you open your browser and go to Canvas. Canvas, being the school's internal platform for coursework and stuff, is running on the school's intranet. It's a private resource, accessible because you're authenticated on the school LAN. The actual Canvas application and your assignment data are likely hosted on a server, or more realistically, multiple servers, within the school's data center, or maybe even a private cloud instance managed by the school.
So Canvas lives on the internet, running on a server.
Exactly. Now, let's change the scenario slightly. You go home. You still need to submit that assignment. You connect your laptop to your home Wi-Fi, your home LAN. You then start up the school's VPN software. That VPN creates a secure tunnel over the public internet, connecting you back to the school's network. Now, when you access Canvas through that VPN connection, You're essentially using an extranet. You're an external user being granted secure, limited access to the internal resources.
Ah, so the VPN makes it an extranet connection.
Right. And throughout all of this, both on campus and at home, the school's main router, and likely your home router too, is playing a critical role, directing your data packets toward the campus server and routing the responses back to your laptop, ensuring the data gets where it needs to go, potentially crossing multiple networks to do so. Your home connection also involves your modem talking to your ISP. So yeah, that one simple act, submitting an assignment, touches on almost all these concepts: LAN, Intranet, Extranet, client, server, AP, router, switch, modem. It really shows how layered and interconnected it all is.
Wow, yeah. Seeing it laid out like that makes you realize how much is happening just below the surface for everyday tasks. Okay, so wrapping this up, what's the big takeaway for you, the listener? We've journeyed from the basic idea of a network through the different types like LAN and WAN, figured out access with internet, intranet, extranet, and identified the key hardware like routers and switches. The goal here really was to equip you with a better understanding of this, well, invisible architecture that basically runs our digital world, to make these concepts feel a little less abstract.
And hopefully now that you can sort of visualize these digital roads and the traffic on them, maybe it changes how you think about things. For instance, understanding these layers might make you think differently about online security or privacy or even what might be going wrong the next time your internet connection feels sluggish. It gives you a framework.
That's a great point. So maybe start looking out for these networks in action in your own daily life. You might be surprised how much clearer that digital world starts to look.